in 6.1, we're looking at systems of equations and two variables, and we look at how to solve these systems of equations. A system of equations, if you look at examples 1 and 2 and 3 and so on, you'll see two equations there. We have three ways to solve them. The first way that we're going to look at in example 1 would be to graph. I really like this method because it illustrates what it means when you have a system of equations and what the solution really is. When you have a solution, it could be one of three things. You could have two lines and they could be drawn out, and the solution to the two lines, the solution to the system of equations would be that point that they cross at. You're always going to get an xy. And that's the solution to the system. That's why graphing is a really good method. We call this a consistent independent solution. Sometimes you graph the lines and they're parallel, and that is an inconsistent independent solution. And then other times you may graph the line and then graph the second line. Let me get a different color for this. And the second line just grabs right on top of that first line. And that happens, and that would be all real numbers, but it is a consistent dependent solution. So let's look at the first example. I've labeled these equations 1 and 2, and I'm going to graph them both. I think the easiest way to graph is to put the equation in y equals form. So I'm working with equation 1 here. X minus y equals 5. So I subtract x from both sides, and I get negative y equals negative x plus 5. And you're wondering probably, or you may be wondering, why I put the x in front of the 5, because I'm putting it in y equals form, therefore I want it to be in the form of y equals mx plus b. So yes, I could have written down negative y equals 5 minus x, but I wanted the x up front. So I kept the x negative, and I just added the 5 to it. So let's finish this, this form out because we're not quite in y equals form. We're going to divide everything by negative 1. And we get that y equals x minus 5. So when we're in this form, the number paired with the x, the m, is the slope, and the number paired with the b is the y-intercept. This means this is where we cross the y-axis. So our m in this case is 1 because there's not a number in front of the x, and it looks like we cross the y-axis at negative 5. So let's do equation 2. So we have 2x plus y equals 1. I'm going to subtract 2x from both sides. And then I'll have y equals negative 2x plus 1. So we're already in that form of y equals mx plus b, where our slope is negative 2 and our y-intercept is 1. I went ahead and graphed these lines using an electronic program, but the first line is in red, the y equals x minus 5. And with this line, you can see that y-intercept is at negative 5, and we just went up 1 and over run. Slope is rise over run, so we think of slope as a fraction. Since this number right here was 1, we put it over 1 to make it a fraction. The second line is in blue. So our y-intercept is 1. And with the slope of negative 2 and slope being rise over run, of course, you can think of it as negative 2 divided by a positive 1 or positive 2 divided by negative 1. Let me show you what I mean. If we rise, and then this is the option I'm working with first. If we rise negative 2, that's really falling 2 units, and you would run positive 1 to the right. Okay, so that's one option. Or from this y-intercept, we could have actually risen positive 2 units and ran, see that 2 divided by negative 1, when you run in the negative 1 direction, that's running 1 to the left. And either way, either option you choose, it gives you the same line. So there's your lesson in graphing lines, but what makes this a solution to the system of equations? Well, these two lines cross, they intersect right here at what looks to be 2, -3. And since these lines intersect, we call this a consistent independent solution, and the solution is 2, 3.